Hello everyone, and today I will be covering the first lab on CCNA security, configuring devices for use with Cisco Configuration Professional. CCP is the short term for it. This is the first time I'll be covering CCNA security. I'm currently still working on CCNA. However, I've managed to attain the CCNA security labs, so I thought it would be beneficial to myself and to those who are interested to go through these labs. I will be using GNS3 for this. I've got some images already from previous projects I've done. And to replicate the PCA and PCC, I'll be using Windows 7 clients and VirtualBox. So I've already done the topology setup, pre-configured it. I'll show you my PCs. So that's one Windows 7 PC which has got CCP on it installed already. The reason I did some of this, well, not some of the lab earlier, the reason I've already got CCP set up is because I had a few problems with CCP earlier. It didn't want to connect, it didn't want to allow me to connect. So as you can see there, we've got discovery failed at the minute, which will become more apparent later. However, we're looking to change that later on. So that's on one Windows 7 PC, and we have the second Windows 7 PC. This PC is Win7-2, which will be acting as PCA on the left side down here. So we're going to jump right in and we're going to start configuring. I'll just read you guys the background scenario. So Cisco Configuration Professional is a Windows-based device management tool for integrated service routers. CCP simplifies router configurations through easy-to-use wizards. The objective of this lab is to verify that the routers and PC are configured properly for use with CCP. Note, in short, that routers and switches are being erased and there are no startup configs. These are clean routers. We've got 3 routers. I'll be using these 3 up here. I won't be using the 1841. However, mine is version 12.4, I believe. We'll just have a look now. And it has got K9 features on. I'll just do a show version. Yeah, so it's version 12.4. We've got K9 security features on, which is what we're going to need for this lab. So we've got the PCs, we've got the switches, which are just going to be acting as pass-throughs. There's not going to be any configurations on them. We just got a note here. If the PC is running Windows 7, which I am, it may be necessary to right-click on the Cisco CP icon or menu item and run as administrator, which I've also done already. As I said before, I was having a few problems with it earlier, but I may have sorted that out now. I also want to point out for those that are following this lab using GNS3 as well, or live equipment even, be sure to make sure that your Windows or your end user clients antiviruses are turned off in order to ping one another on each network once we've set up the full topology. So we've done step 1, we've cabled the network already. Step 2, configure basic settings for each router. So host names are already configured, as you can see. We're going to configure a clock rate for routers with a DCE serial cable attached to their interface. Routers R1 is shown, so that's just the configs for that. And we'll just look at the topology because it should be, yeah. So router 2's interface serial 001. That's also DCE. So we'll do that now. And as well as that, we'll also configure the interface IP addresses as shown in the IP address in the table. So I'll tell you what, before we'll do the clock rate as we go along and do the configurations. So we'll stay up here and we'll start with router 1. And we're consoled in now. So we'll do the IP addressing. Some of these interfaces, because I'm using different images on GNS3, are different to, say for instance, F06. So I just need to make sure once we get in which interfaces are which. So I'll just scroll over. So we've got, we'll do that one. Yeah, we'll configure the IP for the PCs after. So we've got Ethernet fast Ethernet 00. So we'll do interface 00. Just confirm that. Yep. IP address for the LAN interface is there we go. So it's 192.168.1.1. Class C subnet. Enter, and we'll apply the no shutdown command, and the interface should be activated. There we go. Now we'll do the serial interface. Serial 00, I believe it is, and the IP address is 10.1.1.1 255.255.255.252. Yeah, that's correct. We'll apply we'll do the clock rate, which was 64,000. So that's a clock rate done for that DC, and we'll do a no shutdown. And the state's changed to up. So we just exit out of there, and we'll move on to router 2. So we'll do interface serial 00, which is connecting to router 1. IP address is 10.1.1.2. Subnet 255.255.255.252. It's not a DCE, so we won't be applying any clock rate on it. We'll just apply the no shutdown command. And we'll move on to serial 01, interface serial 01, and apply the IP address, which is 10.2.2.2 255.255.255.252. And this is a DCE, so we'll apply the clock rate of 64,000. Then we'll follow it with the no shutdown command, or no shut for short. So that's router 2 done. Jump onto router 3 now. Interface serial 01, which connects to router 2. IP address is 10.2.2.1 255.255.255.252. 221, yeah, that's right. not a DC, so we'll just apply the no shutdown command. Then we'll do the LAN interface, which is fast Ethernet 00. So fast Ethernet 00, and the IP address for that interface is 192.168.3.1 255.255.255.0. Apply the no shutdown command, and that's the interfaces configured with IP addresses, apart from the two end devices, which we'll do now. So we'll do PCA. We'll configure that one now. So PCA is Windows 7-2, which is this one. So we will configure the IP address for this. And the IP address is 192.168.1.3. Class C subnet, and the gateway will be 1.1. We'll change that now. And that should take effect. There we go. We'll just set it as all network. Then we will configure PCC, which is acting as Windows 7 there. So Windows 7, which is this one. And the IP address for PCC is 3.3. Change that 255. Then the gateway should be 3.1. Apply them changes. There we go. And that's that done with the IP addressing. So as we move down, so we've done the topology, done the IP addressing scheme, we've done the DC interfaces for router 1 and the interface for router 2 there. Now we need to do the no IP domain lookup to prevent translations from incorrectly entered configurations. So we'll do that simply now by just entering a command, which is no IP domain dash lookup, enter. Jump onto the router 2, no IP domain dash lookup. Jump onto router 3, exit out of the interface, no IP domain lookup, and that's that done. So now we're on step 3, configure routing protocol on R1, R2 and R3. Static and dynamic routing protocols are used in different chapter labs. Please refer to the chapter instructions to determine which routing protocol is used in a chapter lab. Okay, so we're going to configure static default routes on router 1, 2 and 3. So we'll start with router 1. And we're going to do an IP route to 0, 0, 0, 0, 0, 0, 0.0.0.0, and the next top interface is 10.1.1.2, which is the router 2's interface connected to R1. So we'll do that. So then we'll do the same for router 3. IP root 0.0.0.0.0.0.0.0, and its next stop IP is 10.2.2.2. Configure static groups from R2 to the R1 LAN. Okay. So 192.168.1.0 is that LAN. So we're going to configure that on a router 2, and the exit interface is 0.0.0 on router 2. So basically any traffic destined for 192.168.1.0 network, it'll be passed on through that interface. So we'll do that now. So take IP root 192.168.1.0 255.255.255.0, and the exit interface is 10.1.1.1. Then IP root for the other side 192.168.3.0 255.255.255.0, and it'll be 10.2.2.1. There we go. So we are on to, if we just, before we do that, we'll just do a show IP root, and we can see that we've got 2 static routes connected, which we've just configured. Then we'll move on to router 1 just to check that we've got the default route. Show IP route. So you can see we've got the static default route configured as well. And we'll just check now on router 3. Show IP route. And there you go, we've got the default route there configured as well. So that's that done. So now that we've confirmed the default routes, we are now on step 5, so we're going to configure EIGRP routing protocol on router 1, 2 and 3. So for those out who haven't come across EIGRP, basically for router 1, let me just get my pen out. So for router 1, we're going to configure the network for this LAN and this interface, or that connecting to that. Then for router 2, we'll configure that so that it joins up with router 1, and we'll configure that interface. And for router 3, we'll configure that interface to join up with router 2, and we'll also configure the LAN as well. So we'll get started with that now. So we start off with router 1. We already got that. There we go. Yeah, so we'll start with router 1. T router EIGRP1 and AS number 101. Network 192.168.1.0, 0.0.0.255. And we'll add the serial network, which is 10.1.1.0.0.003 wildcard mask. And we also enter the command no auto summary, so it doesn't summarise and it works automatically. So that's router 1 done. Move on to router 2. And there's conf T. Global configuration, and again router EIGRP 101, and the network is 10.1.1.0, 0.0.0.3, and again there we go, we've got a neighbour adjacency now, so that's showed that it's worked, which is good. And we'll add the other network for serial 01 connecting to router 3, which is network 10.2.2.0, 0.0.0.3 wildcard mask, and that's that network there added. It won't form an adjacency as of yet until I've configured router 3 for EIGRP, but before I do that I'll just do a no auto summary on router 2 as well. No auto summary. So we'll do router 3 now. Conf T. Router EIGRP 101. And we're adding a LAN network, which is 192.168.3.0. Wildcard mask 0.0.0.255. And we'll add the network for the serial interface connected to router 2, which is 10.2.2.0, 0.0.0.3 wildcard mask. And we should get an adjacency formed. There we go. So that shows that we've successfully configured EIGRP now. No auto summary. There we go. The neighbours now formed. So if we do, in fact, yeah, we'll do it on there. We'll do show EIGRP neighbour. No, show IP EIGRP neighbour, sorry. And you can see there we've got a neighbour adjacency to router 2. And if we do that on router 2, we should have 2 neighbours. We'll just check, and you can see there as well the neighbours formed as well. Show IP EIGRP neighbour. So there we go, we've got 2 neighbours, one going out of serial interface 01, which is connecting to router 3, and one going out of serial 00, which connects to router 1. So as we move on, we are now asked to configure the PC host IP settings, which we've already done, so we'll ignore that. We'll move on now to step 7. So verify connectivity between PC and routers. So now we've got to ping from router 1 to router 3. So we'll do that now. and ping. Let's just have a look at the interfaces again. So we're going to ping from router 1 to router 3, which is 10.2.2.1. So we'll ping 10.2.2.1, and success rate is 100%, 5 out of 5. So we know that that's successful. So we scroll back down. Ping from PCA on router 1, on the router 1's LAN to PCC. So what we're going to do now is we're going to ping from the Windows 7 PC to the network interface card PCC. So we'll do that now. So we'll jump onto Windows 7 2 CMD ping 192.168.3.3, and as you can see there, the pings are successful, which is good. Now if anybody's doing this lab or following me through it, do be aware that pings can sometimes fail from LAN to LAN, especially if you're using virtual images, because the firewalls are not allowing it. So if you are having that problem, disable your firewall and it should be successful. So we know that that's successful, which is good. So where we're going here, yeah, that was successful. Now we are on to part 2, router access for CCP. So in part 2 of this lab, you set up a router for use with CCP by enabling HTTP HTTPS server, creating a privileged user account, and configuring SSH and telnet access. So we'll do that now. The CCP is installed on the Windows 7, which is there. So we'll go from this, we'll configure router 3 for them settings. So let's get started. So comp2. Now we're going to do enable the HTTP server, so it's IP HTTP server, enter, so that's enabled it. Then we're going to do IP HTTP server secure server, enter. So it's generated RSA keys there. Please do note that you need to have a K9 image in order to use that command. So now that that's done, we'll do IP HTTP authentication tool. Oops, not tool, sorry, local. And as it says there in the notes that I've just mentioned, HTTPS is enabled only for cryptography enabled Cisco iOS software images. So do be aware of that. Step 3, create a user with privilege level 15, which is pretty much full rights. So we'll do that now with the username, and I wanted to use admin, privilege 15, password Cisco 1 2 3 4 5, enter. Now that we've done that, we move on to step 4, which is configure SSH and telnet for local login. Okay, so we'll do that on the VTY line. So line VTY 04, login local, transport input SSH, and we do telnet, transport input telnet SSH, enter, and exit, and that should be done. Now we move on to the CCP installation and initial setup. Now, as I told you guys at the start of this lab, I did install CCP before starting this video just to save time, as it can take some time and setting up can be a problem sometimes, which I did find out also. I just want to let you know that you can download CCP for free from the Cisco website. You do need a login username to accept their terms of usage before downloading it, so do bear that in mind. I won't go through all the installation steps. However, if you guys actually want to see a video of me downloading and installing CCP ready for setup, then do just request that in the comments, and I will do my best to get that video to those that need it. So I'll miss this section out until we get to step 2, which is create manage communities, and I'll just read this section to you. So it says CCP 2.5 can discover up to 10 devices in a community. If desired, the information for both router 1 and router 3 can be included in one community if the PC has network connectivity to the routers. Only router 3 is discovered on PCC in this section as an example. Right, okay. So on PCC, start CCP. So we'll do that now. So we've got our CCP there. We've already started it. In the select manage community window, input into the appropriate fields the router 3 IP address. So we'll do, let me just delete that. There we go. So we'll 192.168.3.1. We'll enter under username the username we created, which is admin, and the password was Cisco 12345. And press OK to continue. I'll select connect securely as well, which is SSH, I believe. Yep, HTTPS. So I'll add that. Step 3. Click Discover on the dashboard to discover and connect to router 3. If Discover fails, click the Discover Detailed button to determine the problem so that you can resolve the issue. So we'll select Discover. It turns to Schedule first. Then we get a security certificate that should pop up. There we go. Are you willing to accept the certificate asserting 192.168.3.1 a trusted site? I'm going to click yes. There we go. It's changed to discovering on the status. Just give that a minute. Hopefully, fingers crossed, it should work. So moving ahead while waiting for that, B says, once the route has been discovered by CCP, you are ready to configure your select community member. In this example, the select community member is 192.168.3.1, which is specified in the circle there, which should come up here. Once we've finished discovering, it should hopefully be displayed in there. And it's being discovered, so the host name's being picked up, which is router 3, and the connection is secure. So we'll move on. And that's the end of the lab. So the main objective of that is to get CCP configured. Let's see if we can have a little play with it, even though there's our community, as we were talking about. Select community member. Let's have a monitor the root router, overview. Just play with a few feet. I'm pretty new to CCP myself. So it is good just to have a play around on Aussie, you know, once you've done this lab. If you've followed me doing it, you know, do have a play about. Don't just leave it there because the lab's finished. Does take some time to load. Just give that a second. But yeah, that's pretty much the main aim of the lab, really. So as I say, guys, you know, if you do want to see me installing CCP from scratch, please do drop me a comment in this video and I will download it and install it. For those that have already got it but haven't played with it, you know, if you follow this lab and get everything connected that it should be, you know, have a play with this, which is what I'm going to do as well. But any more questions, you know, please feel free to, you know, drop them comments in that box and I will get back to you as soon as possible. We'll just give this a minute just to see if the status loads. If not, then we'll call it a day. However, as I say, I will be having to play around with this and just seeing what you can do with CCP, because it is required throughout a few labs on the CCNA security labs that I've got. The connection has been lost. Rediscover this device to continue. Okay. Right. Okay. So we get firewall status, we've got VPN status, interface status and bandwidth, which is good. However, it has been lost, so we'll rediscover the device. Not sure why it has been lost. But as you can see there, you do get quite a few good details when you click on the monitoring tab, which is good. Manage community, that's the community. Error detected. I wonder if it don't tell me. So we just press discover again. And hopefully it works. It does take its time, I must say. I don't know if that's just because we're using GNS3 and virtual machines, or if that's just how it is. But you know, it does take its time. However, I'm gonna end it there because, you know, we've seen that we've connected and we've followed the lab as instructed. If you want to know more about CCP, once I've played with it after this video, you know, drop me a comment and I will get back to you. But that's it for now. Oh look, just before I end it, in fact, we've got discovered with warnings, so let's have a look at that. Router status. Let's see what comes up here. So we can actually see what model it is, the total memory, iOS version, host name, features availability, which is good. So we've got some good stuff there. But yeah, anyway guys, that's it. Thanks for watching the video. Do subscribe and let me know if you have any questions in the comments.